and hi, I will present about introduction. Acoustic and lighting are fundamental elements in design that impact the quality and functionality of space. Acoustic design focuses on optimizing sound quality, speak intelligibility, and reducing unwanted noise. Lighting design involves using light strategically to enhance visibility, create ambience, and fulfill functional requirements. Acoustic considerations are considered in space like concert halls, theaters, and classrooms, while lighting design plays a significant role in architecture and the arts. Both acoustic and lighting design aims to create comfortable and engaged environments, often intersecting in design projects. Next, guideline or recommendation for good acoustic and lighting design in the room. There are two designs, which is acoustic design and lighting design. For the acoustic design, determine the appropriate reverberation time for the room and use acoustic treatments to achieve it. Second, ensure proper sound isolation between areas or rooms to minimize noise transfer. Third, background noise reduction. Implement strategy to minimize background noise levels within the room. Second is lighting design. First, provide adequate lighting for specific activities, minimizing shadows and glare. Second is install general lighting to ensure uniform illumination and create a comfortable atmosphere. For the third is incorporate controls to adjust lighting levels based on the desired mood and activity.
Assalamualaikum, my name is NORHAFISAH binti JAHARSAH and I will present about room description. In this study, Bilik Tutorial 1, located at the Faculty of Civil Engineering and Built Environment, University Tun Hussein Malaysia has been selected for field work to assess acoustical and lighting parameters, including reverberation time, background noise, and lighting performance. First, for layout and dimensions. The room has a rectangular layout with width of 6.6 meters, a length of 8.8 meters, and height of 3.45 meters. The second one is furniture and seating. The room is designed to accommodate up to 65 persons and is equipped with chair with armrests. Next is window. The room features 3 windows positioned on one side of the wall, allowing natural light to enter the room. This window contributes to the overall lighting condition. Next is lighting. The room is equipped with a combination of ceiling light to ensure sufficient illumination for tutorial section. It has fluorescent lamp tube as the primary lighting fixtures. This light plays a significant role in providing artificial lighting within the room. And the last one is internal noises. The internal noise within the classroom mainly comes from human activities and electrical or mechanical appliances.
My name is ALFIAN FIRDAUS bin Muhammad ABDULLAH. So I will present about the result analysis for reverberation time and also the noise background. So here, as you can see here, this is the result of our group, which is reverberation time. So based on the table above, the position that have been chosen to take the reverberation time is 4 position, which located at every edge of the tutorial room 1. So the size of the room is not too big, so the 4 position that we have choose are enough to cover the entire room. So the volume that have been measured is 196.93 cubic meters, which is within the range of classroom up to 10,000 cubic feet. Hence, the reverberation duration limit is 0.7 seconds. So the reverberation times for certain frequencies are above the limit of 0.7 seconds. For example, at 80 Hz, the position 2 has the higher reverberation time, 2.74 seconds, compared to other which exceed the limit 0.7 seconds. So the other frequencies have the different reverberation time depends on the each position. So at the right side, they have a graph which is the reverberation time versus for frequency hertz for the position, all the position that we have choose. This is a noise background. As you can see here, we use B2 frequency at different position 4, so it gives the result as the table below. So we need to calculate the sound pressure level using the formula given. And then, according to the result above, data that have been obtained by the sound level meter Brune and Gauge type 2250, the background noise at 100 Hz frequency that gives 61.22 Hz is the loudest. So, the longest reverberation time recorded is at position 4, which is give 57.32 Hz. improvements of acoustic. What we need to improve is by selecting materials with the suitable absorption or diffusion capabilities. Next, use a simulator based on the finite element method FEM such as COMSOL multiphasic, which also does optimization. This can offer critical information on the placement of sound absorbing materials, sound oscillating layers, and the best listening posture. Last but not least, each room must be capable of operating independently and must be soundproof. Voice rooms in the different control rooms are generally tiny and offer a high level of isolation.
Assalamualaikum and hi, my name is Muhammad Aliff Haiqal bin RIDZUAN, matrix number AF190020, and now I will present about the result of the illuminance analysis of this room. Firstly, this figure shows the lux value that has been obtained at the study location, which is tutorial room 1. For this analysis, the layout of the room was divided into several zones and the average for the level of illuminance for each zone is determined. The average value obtained is then compared with the average illuminance level set by the Malaysian standard. Then, the table shows the average indoor illuminance of the room and also the recommended average illuminance level according to the Malaysian standard. The permitted illuminance value according to the Malaysian standard is as much as 300 to 500 lux. According to the result of this study, none of the zones surpassed the illuminance level specified by the standard. Moving on to the next slide. This table shows the result of average daylight factor of this room and the acceptable daylight factor value according to the Malaysian standard. According to the standards, the acceptable percentage value for daylight factor is 1% up to 3.5%. Based on the result, all the daylight factor value in this room falls below the acceptable percentage value. From this, it indicates that the amount of natural daylight entering the room is relatively low. For the next slide, this figure shows the illuminance contour for this room. The red color on the contour indicates a high illuminance level exceeding 350 lux. This is because the point is located near the room's window, making the point highly exposed to the natural daylight. The contour demonstrates that only a few areas pass the specified level, while the majority of the room does not. Based on the observational analysis, areas with low illuminance level can be attributed to non-functioning lamps and their distance far from the window, which result in inadequate lighting. Hence, it is essential to adopt a practical approach to ensure that the room receives adequate lighting and offers an optimal level of comfort for its users. For the improvement of lightings, there are several approaches should be taken to improve the qualities of the lighting in this room. The first improvement is repairing the damaged lamp. There are 10 installed lamps. However, some of them are damaged, resulting in a decrease in overall number of functioning lamps. As a result, the room lacks of sufficient lamp for proper illumination, leading to inadequate lighting in the space. Number of fittings needed in this room can be proven from this calculation. Therefore, from the analysis, it confirms that this room needs a total of 10 lamps for adequate illumination. By fixing the 3 non-functional lamps, the number of working lamps can be restored to 10. Ensuring sufficient lighting in the room. The next improvement is optimized natural lighting. This can be done by adjusting the room's layout or furniture arrangement to allow more natural light to enter the space. Additionally, installing light-colored or reflective surfaces such as mirror or light-colored paint can help distribute and amplify natural light, increasing both illuminance and the daylight factor. Then, for the last improvement is adding lighting control system. By implementing a lighting control system, it can provide better control over the illumination in the room. This may involve using dimmers or sensors to adjust the lighting levels based on occupancy or daylight availability. With a lighting control system, the lighting can be optimized to meet specific needs, ensuring that the room is adequately lit while minimizing energy consumption.
For conclusion, the reverberation time for room tutorial 1 does not meet ANSI standards, American National Standard Institute for reverberation time, because the time exceeding the recommended limits of 0.7 seconds for classroom up to 10,000 cubic feet. So we need to implement improvement by utilizing sound absorbing materials, ensuring proper sound isolation, and others. For lighting, the room currently suffers from poor lighting quality, plus with 3 broken lamp, the illuminance levels in most zones fall below the standard specified by MS 1525.
So we need to improve the lighting by fixing the 3 broken lamps and also open the curtain to use to maximize the use of daylight into the classroom. That's all from us. Thank you.